Guys and girls, it's Know It Time!
So the last part of this is actually called and it's actually the ambiguous case for sine law. The ambiguous case for sine law. Harmeet, Anulay, chop. Pass it back. The key word here is ambiguous case. A lot of students are going to get mixed up in here on what to do. So I'm going to show you how to do ambiguous case right now. In order for you to understand the ambiguous case, you need to know a few key things. Number one, sine. Let's give you an example of 50 degrees. Punch in your calculator. Sine of 50 degrees right now. Sine 50. If I punch in my calculator, sine 50 gives me 0.766. 0.766. If I give you a few more, 0.44. Now, that's one of it. But I'm going to tell you this right now. There's another angle besides 50, such that when you punch in your calculator, you get exactly 0.766. 0.44. Find that missing random one. What is that unknown angle? They give you exact same number. Hershey bar? 49.9? No. I was going to say 49.99999 if you're... 410, let's see if you're right. Sine 410. 410 works also. But there's a smaller one besides 410. There's more than one. Okay, let's say here Simon says 130. Let's punch in sine 130. Sine 30. Hey. 310. Let's see if 310 works. No. So 130 works. Let's write this down. 130. Okay? Because sine 130 gives you the exact same thing. Let's see, I'll give you another one. Sine 70. We'll figure out the pattern in a second. Sine 70. 0.939. There's another one I'm going to say that gives you exactly 0.939. 110. Let's punch in your calculator. So a lot of you are starting to see the trick and say, hey, Miss Snow, tricky. Without using your calculator time. Sine 60 is equal to sine of 120. So what's the pattern, Ruby? 180 minus this, it gives you the exact same thing. So the ambiguous case, oh, now you just saw this. Yeah. Here's a case. So here's a formula. It means sine theta equals to the exact same thing as sine 180 degrees minus theta. Whether you understand the ambiguous case or not lies in this one concept. Okay? That's it. If you understand this to be true, this section will be easy. If you say, Mr. Snow, what the heck are you talking about? You're going to be in trouble when it comes to this. Why does this work? Well, we just proved to you. It also lies on, here's the reason why. I want you to draw a simple little triangle. Would you agree that sine is positive in two quadrants? One is here, and one is here. Agree? Would you agree that for this one, this is sine theta? And what about this one? This is sine 180 minus theta. Agree? Because from here to here is 180 minus theta. That's why. If you wanted to look at the triangle. But I'm going to give you a question. They're going to say, how many triangles are possible? Now, the book teaches a lot more complex way, but I'm going to teach you a simpler method. It's going to say how many triangles are possible. And you can get a choice. You have 0, 1, or 2. That's only 3 choices you get. This is called the ambiguous case. ambiguous case only occurs when you are given an angle, a side, and a side. It only occurs when you're given angle, side, side. If you make a mistake on this, you're going to make a blank of yourself. Okay. It only occurs when you're given angle, side, side. For example, I'm going to say this. How many solutions are possible when I give you this triangle ABC? Angle A equals to 39. A equals to 10. B equals to 14. First thing you're going to do is draw your triangle. Now, but you got to be careful. I give you an angle, and I'm giving you two sides, see? When you're given an angle, two sides, there could be more than one triangle possible. So when you work on 4A, a lot of you say, Mr. No, how come there are two answers? Here's the reason how. So draw your triangle right now, please. Triangle ABC. Do it. Label A, B, and C. So here's A, here's B, and here's C. Label in your angles and label in your side. 39, 10. 14. No, whoa. Wrong answer, Harmeet. You give me the wrong answer. Let's erase this. There we go. Come on, erase it. That's 14. The question now is, how many different triangles can I form? In order for you to figure this out, you gotta find this angle B. I want you to find theta right now for me, please. Theta. Okay. Take a minute, find theta. Just exactly what you did before. Find angle theta. Okay, so set it up. So a lot of you went, that's easy, sine theta over 14 equals to sine 39 over 10. Punch in your calculator right now. I'm going to just do it nice and simple. Sine 39 divided by 10 times 14. So a lot of you should have this. Sine theta equals to 0.881. Find theta. So you go inverse sine. See, I didn't do anything hard. I keep it simple. 0.881. Punch in my calculator. And you have 61.7. For now, to make it easier for everybody, I'm going to call this 62 degrees. So theta, roughly 62 degrees. But instead of 62 degrees, so let's draw a triangle right now with 62 degrees. So we're going to keep it simple. One of them, we know is going to be 39, 62. Find this missing angle for me, please. So we know theta. So you go 39 plus 62 minus 180, 79 degrees. So would you agree, if I did this, I have one answer right here. One answer. But this is theta. I also taught you when you have sine, there's another way to get theta. We go back to my formula right here. To understand, we can also go 180 minus theta, and to get you the exact same thing. So we're going to see if there's such thing as theta 2. We're going to write down theta 2 right now. So you go 180 minus 62. I just want to see if there's such thing as theta 2. Because remember, they're all the same thing. So this is 118. I want you to draw another triangle. Is it possible for this angle to be 118 and yet you have all three angles? So draw it in. So see, look what I'm going to do. I'm going to draw it in right now. if this is 39, this is 118, is it possible to get this missing angle? If it is, you have two possible answers. So let's calculate this right now. 180 minus 118 minus 39. Is it possible? Oh, it is possible. 23. So this other angle, so in this case, look at this. I have two answers because I just showed you my two possible triangles. One here and one here. 39? 39 is always there to begin with. No, but I'm going to give you another example. Some of you say, "Mr. then isn't that stupid because all triangles have two answers?" What if I give you this one? I'm going to pause it. I'm going to grab some matchup. Try this one. They're going to say, how many possible answers can you have? And draw your two triangles for me. It's going to say, triangle DEF. Angle D equals to 120 degrees. D equals to 2. E equals to 3. Notice I'm giving you an angle side side. The moment I give you angle side side, be careful. You can have more than one possible triangles. Your job is to tell me how many possible triangles can you create. The first thing you can do is find theta and draw out your first triangle. See if it's possible. And I'm going to pause it and let you try it on your own. I'm just going to start by drawing a very quick triangle. D, E, F. 120 is right here. 2, 3. Let's find angle E. Okay, let's find it. I don't even know how many answers there are. Sine 120 over 2 equals to sine E over 3. If I solve for E, you get something called error. If it's error, guess how many triangles are possible? 0. That's what I showed you before. So this is an example of 0 triangles are possible. One last one. How many triangles are possible? RST. Angle R equals to 103. R equals to 16. S equals to 9. Your job is to tell me how many triangles are possible based on this configuration. I'm going to pause it. First thing you're going to do, just draw out a simple triangle. Very, very simple. R, S, T. See, I keep it simple. R is 103. 16. 9. Let's find this missing angle, whatever you like to call it. So right off the bat, I go sine 103 over 16 equals to sine theta, or S, or whatever you want, over 9. Take a minute and solve for theta right now. Okay, let's solve it. Sine 103 divided by 16 times 9. Inverse sine 0.54808. 33 degrees. That's one of them. So let's write down theta equals to 33 degrees. I want you to draw your triangle right now. Is it possible to create one triangle with 33 degrees? So you have 103 here, 33 here. Let's find another angle. If you can find that last angle, it works. So you go 180 minus 103 minus 33, 44. Here is your first triangle. This works. I want you to find theta 2 right now. Let's see if theta 2 works. Nope, you can't. So you go 180 minus 33. My theta 2 is 147. Draw a triangle with 103, 147, And you're going to realize something. 103, 147. There's no such triangle because right off the bat, these two are greater than 180 degrees. So in this case, you only have one triangle. This is an example of one solution. So guys and gals, that is called the ambiguous case. Is it that much harder? No, not really. It's kind of fun. You guys check it, draw your triangle. This is why I waited for you to have some practice with sign law before I can teach you this. Your work. Oh, no, you have one for today. That's good enough. Oh, I may will give you a redeem tomorrow. For now, Pache! 6 a day. 108. Number 6. And number 8, that's it. Guys and gals, I'm nice today. I'm feeling very generous. That's it. You have over 20 minutes